All right, so we're going to continue in chapter 3 into section 3.3. And just as a reminder, in section 3.2, we talked about synthetic division and how to use that using the remainder theorem and how to check to see if certain numbers were zeros of the equation. And so we're going to now move into still using synthetic division, but talk about the factor theorem. And so the factor theorem says that for any polynomial function, again, we'll call it f of x minus k is a factor of the polynomial if and only if f of k equals 0. So think about that. If you were to take, let's just say, something like x squared plus 5x plus 6, and you were to factor that, we would say we need two numbers that multiply to give 6 and add to give 5, so it'd be 3 and 2. Signs are the same, they're both positive. And if we were to say this is equal to 0, then we would say, okay, well, those two numbers or those two factors would be able to, we could use the zero factor theorem to show that what x is going to be when you solve for x. And so we would say, well, x plus 3 equals 0 and x plus 2 equals 0, 2 equals 0. And you would solve and you'd find out x is negative 3 and x is negative 2. Now, the reason all this works together is because if we were to do synthetic division with negative 3, we would find that the remainder is 0. Meaning that negative 3 can be put in place of x in each of these x's, and when you simplify that, or when you simplify the left side, you get 0, which is equal to the right side. That number makes the equation true. You could also take negative 2 and do the same thing. And so if we know that putting those numbers in is going to give us 0, well, that means that those two, x minus those numbers, have to be a factor of the polynomial. And so this is going to allow us to factor a polynomial that's got a cube, for example, instead of just a square. So we've talked about factoring all through this class, and we've talked about how to factor primarily quadratics. Worked in a few cubes, but not much. And so we haven't really talked about, well, how do we find the solutions or even factors of higher degree equations? And so the factor theorem is going to allow us to do that. If we can show that x minus k is a factor, then what that means is that if you were to take k and put it in that equation, it would make it equal to 0. So in other words, 0 would be your remainder. And so hopefully through our synthetic division, we can very quickly show what our solutions are, and we can use this to factor different polynomials. So let's look at some examples. I think this will make more sense as we work through some problems. So as we look at this, the first problem here says that we want to determine whether x plus 4 is a factor of the polynomial. Now, remember, x plus 4, we're talking about x minus something, right? It needs to be in this form, x minus k. So x plus 4 is the same thing as x minus negative 4, right? Because we know that minus a negative does make it positive. And so the number we're going to use in our synthetic division is this negative 4. And so we're going to do the synthetic division, and if we get 0 for the remainder, that tells us that negative 4 would be a solution, but it also tells us that x minus negative 4, or x plus 4, is also a factor of the polynomial. So let's try that. So we're going to take negative 4. We're going to use that in our division. Now notice when we do our synthetic division, we have x to the 4th but we don't have x cubed, so we'll have a 0x cubed, and then we have x squared, and then our x, then our constant. So make sure you put the 0 in. Again, don't forget that it's a placeholder, essentially. So we're going to put 3, we're going to put 0, negative 48, 8, and 32. Now, here's the thing about this. When you put these numbers in and you start simplifying, you may very quickly be able to figure out if the number is not going to give you 0 for the remainder. And if you realize that, you technically could stop and say, okay, well, this number is not going to work. I would encourage you to go ahead and go through the synthetic division, but sometimes you're going to see, well, there's no way these numbers work out to give me that 0 for the remainder. So let's look at the first one. Let's try it and see what happens. We'll start by bringing down the 3. And then we'll take the 3 and multiply by negative 4 and get negative 12. And negative 12 plus 0 is negative 12. Negative 12 times negative 4 is a positive 48. Negative 48 plus 48 is 0. 0 times negative 4 is 0. 8 plus 0 is 8. 8 times negative 4 is negative 32. 32 minus 32 is 0. It does now give us that remainder of 0. So, to answer this question, we would say that yes, x plus 4, because again, x minus negative 4, x plus 4 is a factor of the function, or of the polynomial. You could say that too. Since that's the word that actually uses, we probably should use that instead of function. But either way, we are saying that yes, x plus 4 is a factor. Now, again, it's just synthetic division, but it's then taking what we get from that synthetic division and making some sense from it. And so in this case, we say that the x plus 4 is a solution. Now, let's try it here. Again, we want to know, is x plus 4 going to be a solution or be a factor of this polynomial? And so, again, x plus 4, remember that's x minus negative 4. So again, the negative 4 is what we're using when we do our division. And if you look at all of our terms, we have an x to the 5th, x to the 4th, x cubed, x squared, x and constant. And so we don't have any zeros that we have to put in. So our coefficients are going to be 1, 6, 11, 12, 5, and negative 20. And so again, we'll do our synthetic division. So bring the 1 down. 1 times negative 4 is negative 4. 6 minus 4 is 2. 2 times negative 4 is negative 8. 11 minus 8 is going to be 3, not 2. I was looking at the one beside it there. Then 3 times negative 4 is going to be negative 12. 12 minus 12 is 0. 0 times negative 4 is 0. 5 plus 0 is 5. 5 times negative 4 is negative 20. Negative 20 minus 20 is negative 40. That is not going to give us 0. And so, in this case, we know, after running through that synthetic division, that x plus 4 is not a factor. And so we're going to say, no, x plus 4 is not a factor of the polynomial. Again, if you have questions about that, if I need to explain something in further detail, shoot me an email, let me know. We're going to look at a couple more examples, but if you have questions, definitely need to make sure you let me know. All right, so notice that this one now says something different than the previous. Previous one said determine if x plus 4 is a factor. This one now says to factor this polynomial into linear factors given that 5 is a 0. Okay, so a few minutes ago we talked about if we were to factor, you take your factors, you set them equal to 0, and you solve, and you say, oh, this number is a solution, or this number makes the equation 0. So a solution is a 0. Okay, same thing. And so if 5 is a 0, then when we do our synthetic division, we're going to use 5. Now, you may say, well, why are we going to do synthetic division? Well, if I can take that 5, and I know for a fact it's a 0, then I should get 0 for my remainder. And the polynomial that is left should be a binomial. I'm sorry, it should be a trinomial, but it should be a quadratic. Because we know our answer, if we start with the power of 3, our answer is going to be starting with the power of 2. So it's going to be a quadratic. We can factor and solve that equation. We're just asked to solve, but we could even, we're asked to factor, but we could solve it if we needed to. So when we do our synthetic division, we're going to put the 6, the negative 37, 32, and 15. Now, if you do the synthetic division and you do not get 0 for your remainder, you messed up. Because it tells us that 5 is a 0. And so if that is true, then our answer, our remainder should be 0. Okay? So just be aware of that. If you don't get that, then obviously you know you've messed up. Now, we're going to take the 6, we're going to bring it down. 6 times 5 is going to be 30. Negative 37 plus 30 is negative 7. Negative 7 times 5 is negative 35. 32 minus 35 is negative 3. Negative 3 times 5 is negative 15. 15 minus 15 is 0. So that one does give us that remainder of 0. Now, here's the why we do this. Because when you divide this original polynomial, this one, by x minus 5, because remember, if 5 is a 0, then x minus that number is a factor. So x minus 5 is a factor. And so if we're trying to factor this polynomial, we already have one of them. That's given to us in our problem initially. And if you'll notice that when you divide by that, what's left now is 6x squared minus 7x minus 3. Well, can you factor that? Well, sure, I hope so. We have factored polynomials like this for a long time. And so if you take that 6x squared minus 7x minus 3, and you factor it, if you've been in my class, then you know that I typically will use the bottoms up method, where we take the 6 and multiply by negative 3. And we'll have x squared minus 7x minus 18. And then we can factor that. So we're looking for two numbers that multiply to give 18, that will subtract to give 7, which is 9 and 2. Signs are different. Biggest number gets the negative. And then because we multiplied by 6, we'll divide the 6 back out. And then when we simplify, 9 over 6 simplifies to 3 over 2. And 2 over 6 simplifies to 1/3. And then those denominators get moved up. Again, that's why we call it bottoms up. We move the denominators from the bottom of the fraction up in front of the variable. And so our final answer, or final factorization from the trinomial, is 2x minus 3 times 3x plus 1. Now, the question is to factor this original polynomial that's got 4 terms. Because there is a power of 3, this exponent of 3 tells us there should be 3 solutions which also means there should be 3 factors. Okay? So, to factor that, we already have 2 of them. You see those here. The other factor is x minus 5. And so we need to write it with the rest of them. So there is the final answer. That's our final factorization of this. So that polynomial factors into those three factors. If we were asked to solve this, we could set it equal to 0, and we could solve by setting each factor equal to 0. And you actually would have 5, 3/2, and -1/3 as solutions to this equation.